as we begin today, want to start by taking a look at speed drill number 20 there at the top of page 21. Speed drill number 20, and we're going to just take it easy on you today. We're just going to do adding and subtracting. So back to the basics here, and you'll have 3 minutes to do just 8 problems. So there should even be plenty of time for you to work through, though I wouldn't check until you finish all of them first. Speed drill 20, you have 3 minutes, and you may begin. Do either of you need to visit the library? Both of you do. All right, now be in about 20 minutes or so. Just about a minute remaining. Stop. All right, go put your pencils away and take out a pen. Pencils away and take out a pen. I'll give you a few extra seconds this time just because I feel like I'm in a good mood. All right, a few extra seconds for this. And pen out, let you check your own. And these are 12 points each. 12 points each. All right, going across the top row, the addition problems. 2,104. 21,592, 116,733, 41,191. All right, any repeats on the top row? All right, next row. 1,533, 8,868, 308,027, and 1,355.
For First one on the bottom row?
Yes, 1,533?
Yes.
34. Let's try 1,534. I was just seeing if you were paying attention. Okay, no, I screwed up. Yeah, I did write my own answer key on these, and obviously did a bad job on that one. All right, sorry about that. Good catch. 1,534, the first one on the bottom row. All right, any other questions on those? All right, 12 points each. So I got an 88. 12 points each, minus 188, minus 276. Hopefully we didn't miss more than one or two.
I wondered if I got a chance to fix the carrying area.
I
realized it.
So
right
88?
before, yeah.
All right, so we got the same score. How about you, Lana?
I got 100.
Show off. All right. All right, good job on that. And let's go ahead and take out your homework from last night. Homework out from last night, page 406. Review numbers 14 through 22. Page 406. The review numbers 14 through 22. And going back in time a little bit, right? Talking about percentages and percents and base. And remember we said with these percent type problems, we could remember that the word is class means equals. Of means, and a decimal must, or a percent rather, must always be written as a decimal. Percents must be written as decimals. So when it says 100, well, this is stupid easy, but when it says 100% of 16, we're going to make the 100% into a decimal class. 1. And of means multiply by 16, and of course we get 16. That one shouldn't have taken you real long. How about 15% or 0.15 of or times 240, Lana? 36. What about 36% of 112, Joshua?
40.32.
Good, 40.32. Number 17, 45 is what percent of 36? Now you realize 45 is bigger, isn't it? So you know you're going to get something that's bigger than 100%. Lana, we're going to get
125%.
125%. Good. 24 is what percent of 50? Well, again, think. 24 is a little smaller than half, right? Half would be 25, right? So we're expecting something a little smaller than 50%, which would be half. We do get what, Joshua? Number 18.
Yeah. 48%.
48%, just a little smaller than half, which would have been 50%. Remember on something like that, when you make the fraction 24 over 50, instead of actually doing the division, make equivalent, make it a denominator of 100, multiply by 2 to get 48 hundredths, which is 48%. Might be a quicker way to do that. Also, 240 is what percent of 400? Well, again, you make this a fraction, Lana, and if I wanted to go down to a denominator of 100, I just divide by 4. So if I just divide by 4, I could get 60 hundredths, or 60%. Is that what we had for 19? Now again, you can do it the division way, and there's nothing wrong with that, but sometimes equal ratios help. And then for number 20, you're finding the base. 40 is or equals 80% or 0.8 of or times what number? X. Dividing away the 0.8, Joshua gives us 50. And that makes sense, right? 40 is 80% of 50. 4/5, 80%. 24 is 80% of what number, Lana? 30. And 92 is 4% of what number, Joshua?
2,300.
2,300. We'll be perfect on the homework. Excellent job on that. Just some review on percents, things of that nature. Turn over a few pages, turn back a few pages to page 402. And I want to review with you some things you should have learned last year in 7th grade dealing with statistics. I want you to note this word first, data. Data. At the very top of your page, you see that bold term. That's any collection of facts or information. Data is simply a collection of facts or information. I could find out how tall all of you are, how old all of you are, what your favorite foods are to eat, all those different things, right? That's data. That's just facts or information. You collect it all together. Usually what we'd want to do, though, is collect, like I said, related data, right? Related data, like all of y'all's heights. Like his height doesn't really relate to her favorite food or his hair color, right? Those don't relate. But all of y'all's heights, that'd be a good collection of related information, data. Statistics, you notice there, has two definitions, okay? The first is the branch of mathematics that studies data. I want you to also jot this down. Statistics is also used to refer to numerical data. Statistics also refers to numerical data. So where data could be words, right? Eye color, hair color, favorite food, favorite restaurant, city you were born in. That's information, that's data. But that's not numbers. How tall you are, what grades you make, how much money people make, how old people are. Those are numbers. Those are statistics. Numerical data is statistics. And as we study statistics, especially with a large group of people, commonly what we'd want to know is what's kind of normal. Does that make sense? Well, the shortest person in the world isn't normal, is he? Or she. I don't know if it's a he or a she, right? That's not normal, right? The tallest person in the world isn't normal, right? Most people aren't like Shaquille O'Neal. So if we want to find what's normal, we would want to find what's kind of the middle, right? If we took everybody and lumped them together, what's kind of in the middle of it all? And that's referring to measures of center. And you see that term there in bold. Measures of center give us ways in which we can summarize a set of data by giving us these middle values, or these normals, if you will. 3 measures of center that you should have read about last night. The first you see there is the mean. The mean. The word mean means average. Underline that word average. You've known how to average stuff for years. Add up all the stuff, divide by how many there are, right? That's all the mean is. I want you to note this, and you may need to write this down off to the side. The mean is particularly useful when finding the normal, or the measure of center, for large data sets. The mean is useful in summarizing large data sets that contain something called outliers. So the mean is useful for finding the middle, if you will, or the measure of center for large data sets that contain outliers. Now here's the deal. If I wanted to find what's kind of the, I don't know, the normal height of people. And so I went and asked 5 people how tall they were. Am I going to get a good sense of how tall folks are? Nope. Not asking 5 people, right? The mean is not probably a good method to use. This is particularly true, by the way, for quizzes, right? I give a quiz to a class of 5 kids. We might have a kid make 100, we might have a kid make a 60, and we might have a kid make a 90. Well, the average is going to come out to like an 83. Is that the normal? Is that kind of what everybody in the class made? Well, no. We're all over the place, right? But if I had a class of 30 kids, which is what I had at the school I was before here, these classes were about 30 kids. Well, there, if the average score is an 82 or 83, you had a whole bunch of people in the 80s and 90s range, maybe a couple in the 70s range, maybe 100 or 2, maybe a failing grade here or there, but it really was a better sense when you get more numbers, right? A larger set is where you want to use, it's not up there, the mean. Now, an outlier is a number that's just unlike everybody else. For instance, when we talk about how much money does the average person in America make in a year, well, you remember there are billionaires in this country, right? Are they normal? Not in the sense of how much money they make, right? That's not normal. Most people aren't making billions of dollars. In fact, if you were to look at how much money people make, most people are in that 30 to 60,000 a year range. And there's a good number in the 60 to 100,000, and even still a decent number in the 100 to 150,000. But once you get over about 150 to 200,000 a year, there are a lot fewer people making that kind of money. There are also some people at the other end of the spectrum who are living on welfare and they're not making anything but what the government gives them. But that's also not most people in this country. Those are called outliers, numbers that are just so far from the norm. Let's suppose I gave a quiz to, let's just say it's a class of 10, and people made 70, 70, 70, 70, 80, 80, 80, 0. Okay, that's going to really mess up the average, isn't it? Because most of the people in the class didn't make a 0. Just that one person did. And that grade is so far from where everyone else is, it's called an outlier. Well, when you look at the average, though, that outlier is going to really mess it up, isn't it? It's going to make it look like the average person in class made a 68. Everybody made better than 68 except that one kid, right? Okay, so it messes with the average. By the way, this is why it's so important for your own grades, right? You got quiz, 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 test, quiz, 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 test, quiz, 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 test, right? Well, you get 1 0. Man, it can make your grades sink like a rock. Right? It's awful. You cannot afford zeros. That's why teachers say it's better to put down something than nothing. Or, it's maybe a math project in history class, and teacher's like, well, you better turn in something. Anything's better than a 0, because a 0 can just sink your grades so bad. Better to get a 40 on your math project, bad as that is, than a 0, which is so far off, it just plunges your grade. Outliers, okay? They mess up the mean. So the mean isn't always the best thing to use, which is why, I don't know if you ever listen to the news, but when they talk about the normal income in America, they never say the mean income. They say median income. Median is another measure of center that you see down there at the bottom of the page. And this is a good measure of center when there are a lot of outliers, or outliers in general, present. It's also useful, for instance, with smaller data sets to use the median. Median means middle value. The middle value, and you see that there after the word median. Median is the middle value. Now, middle value, you notice it says a set of ranked data, a ranked list of data. Ranked means the data is put in order. The numbers are put in order from smallest to largest, or largest to smallest, generally smallest to largest. When all the numbers are put in order of all the people in the United States, of all the money they make, and you put all of them in order, again, you've got some way down here at the end that are living in abject poverty, or, well, I say abject poverty. By U.S. standards, abject poverty. Most of the world could still consider them rich. They're on welfare. Then you go all the way to the other end of the spectrum. You've got the billionaires who have more money than they know what to do with. They're stupid rich. And you kind of just right to the middle. Well, instead of the average U.S. income being $120,000, which it might be with those outliers, the normal income is like $54,000 a year. Okay, that's actually what the data reflects. More people are making that anyway, so yeah, that's about normal. Median is the middle value. Put all the data from smallest to largest, and then just kind of check them off until you get to the middle one. Now you know this, sometimes you don't get a middle one. You get a middle two, right? As you're checking things off, you'll either come down and whoop, there's one in the middle, or you'll be checking off and like, whoa, if I check anything more off, I got nothing left. So you're left with two middle ones. In that case, for the median, you would average the middle two. You would find the mean of the middle two. Let's look at some examples. Look at example 8.7a. Example 8.7a with the mean. Go ahead and read it for us, if you would. Joshua?
The last five scores for the Warriors basketball team were 59, 72, 46, 50, and 83. Find the mean score for the last 5 games.
All right. And notice these scores are all over the place, right? I mean, they're everywhere. They've got games where they don't score much at all. A couple of games, in fact, where they don't score much at all. 59, I would say, is kind of in the middle. And then 72 and 83. I mean, they scored a lot of points that game. They must have been playing a really bad team. But anyway, everyone was just hitting their shots that day. I don't know which. To find the mean, notice they add them all together. They got 310 total points. Divided by 5 games, got 62. That's the average number of points they scored. Make sense? What if we wanted to find the median? We would have had to put the numbers in order. What would the numbers be in order, Lana?
46, 50, 59, 72, 83.
So you knock off the biggest number and the smallest number, next smallest, next biggest, and notice it leaves you with a 59 in the middle. That's your median. So the mean is 62. The median is 59. Notice those are pretty close together. If the two numbers are pretty close together, that's a good sign that your middle value's pretty much there, right around that 60 mark. Look across the page. Example 8.7b. Now you see, first of all, they did the median already of the Warriors game. But look at part B of example B. They give you all these numbers. I mean, 53, 17, 9, 43, 32. 9 seems really small. 32, 28, 27, 14, 92, 7, 99, and 27. Do you see how there's numbers everywhere? I mean, there's a 99 and a 92, but there's numbers like 7 and 9. There's huge numbers. There's little numbers. Okay, on something like this, finding the mean probably isn't going to give you a good estimate of middle. Here's where we want to find the median. Now, notice they put all the numbers in order. The 9 and the 99, 7, 9 and 92, 14 and 53, 17 and 43, 27 and 32. And notice in the middle are 27 and 28. Well, as you look at those two numbers, since they're both middle values, they average them to get right in between 27 and a half. Makes sense on how to find the median. Okay. All right, now, there's another middle value that we will use sometimes, and that's called the mode. The mode. The mode is the value that it occurs most often, and you see that there. The mode is the value that occurs most often. Go ahead and underline that. This is especially useful for saying what normally actually happens. Again, it's possible that you would get, well, median is generally a value that's actually present, or in the case of 27 and 28, 27 and a half. Remember the mean on the first set was 62. Well, they never scored 62. How is that normal for them to score 62 points when they never scored 62 points, right? Really, truly, the mode is perhaps the best expression of what is most normal, in a sense that this is the value that occurs most often. The problem is, sometimes there isn't. There isn't anything that occurs most often, right? If everything is different, there isn't a most often. So it's possible that you might not have any mode. Another great use of the mode is for non-numeric data. Think about it. What if we were talking about favorite restaurants, right? And we went throughout the entire school, Joshua, asking people what their favorite restaurant was. Well, how can I add those up and divide by how many there are? You can't add restaurants. What if I put them all in order and kind of put what in order? How do you put restaurants in order? Alphabetically? Maybe that's stupid. But if there's one name that just keeps coming up the most often, I don't know, Domino's, I don't know, whatever you like. Okay, he doesn't like Domino's. I like Domino's, okay. I like their price really good. It'd be $7.99, 3-topping large. That's what I'm talking about. I mean, we paid pizza $10 for that 3-topping large. And they recently changed it. Like I used to be able to do 4 toppings on half, 2 toppings on the other half. That's 3 toppings. 4 halves and 2 halves is 6 halves. And Domino's still lets me do that, but pizza, they're like, no more than 3 toppings on either half. I'm like, you used to be so good about this. Now you're charging me 88 cents to put that extra topping on? No, I ain't paying 88 cents. I'm cheap.
It makes sense.
For one topping, like for a few little sprinkles of, what is it, like onions or whatever, 88 cents for a little bit of onion on half a pizza? No, I ain't paying 88 cents. It's almost a whole $1 extra. I know. Anyway, so cheap guy that I am, yeah, $7.99, 3-topping large, but whatever, the favorite restaurant. Maybe it's Chick-fil-A, maybe it's Zaxby's, maybe it's Culver's over in Phoenix City. I mean, all of those sound good to me right now, and I just ate, and I'm still sounds good. But anyway, that's non-numeric. Well, what you can do with non-numeric data is you can say, well, I keep hearing Culver's. Of all the names I heard, Culver's was the most commonly used name. Or maybe there were a couple. Maybe Culver's and Chick-fil-A. Like, I heard those 2 names more than anything else. Okay, then we've got 2 modes. It's bimodal. We could say, write that term in your notes if you would, bimodal. Where maybe there's a couple things that kind of rise to the surface, if you will. Now, I will say, if there's like 4 or 5 restaurant names that are all tied for the most, okay, there really isn't one true mode at that point, is there? Right? It's not in your book. That's why I told you to write it down. Bimodal, okay, is a set of data that has two modes in it, and that is possible. If more than 2 modes are present, though, I mean, some people would argue you could have trimodal distributions, quadromodal. Unless you're representing different sets, if you've got more than 2 things that stand out, nothing stands out, right? It's like, if everybody makes the honor roll, it's like, I don't really feel that honored because everybody's on the list. But if like only 1 or 2 kids make the honor roll, it's like, yeah, I made the honor roll. Yeah. But if everybody's in the honor roll, it's like, big deal, right? Like, everybody's on it anyway, so we're all honor roll, like, good for us. Anyway, so 2 things stand out. Okay, maybe bimodal. 1 thing stands out. That's a true mode. 3 or more things stand out. Nothing really stands out at that point, right? So anyway, no mode is always a possibility. Look at the example problem. The easiest way to spot the mode is to rank the data or organize the data. Maybe it's alphabetically, things like that, but organize the data. Once you've organized the data, you can see here that 38 just pops. I mean, there's a couple 30s, there's a couple 36, but there's 3 38s in a row. Okay, 38 is clearly the mode. It's definitely not the average, the mean. It's definitely not the median because it's up on the high end, but it is the number that occurs most often. So 3 different measures of center class. Mean means
Average.
median means middle, and mode means most often. And those are what we're going to be working with. Turn over to page 405. Turn over to page 405. First thing I want you to do on numbers 1, 2, and 3 is just rank the data. Just rewrite the numbers in numerical order. This is relatively brainless. We're going to start really easy here. 1 through 3, just rank the data. What I would do is after you write a number, cross it out. Once you've written a number, cross it out so we don't accidentally write more than once. I didn't tell you to do that. I just told you to rank the data. Here you are. Like, what is taking you so long?
I didn't use the bathroom.
Uh-huh, yeah. Right over. All right.
Let's do 1 through 3.
All right.
Not
Glenn.
Oh.
All right, number 1, in order, check your answer. 27, 41, 42, 42, 46, 48, 60. Easy enough?
Oh, I forgot 60.
Oh!
I didn't even see it there.
Yeah, check them off. That's make little tick marks as you write them down, so you make sure you got them all.
too, and I still forgot that.
Still forgot to check off 60?
Yeah.
Like you never crossed it out?
No,
Then that means you hadn't written it yet. So if you can still see a number, it means you have to write it.
I didn't see it.
Okay, number 2. 51, 54, 55, 58, 58, 59, 82.
Mm-hmm.
And number 3, 4, 5, 5, 6, 6, 7, 9, 19.
Mm-hmm.
Okay, now, as we're looking at the data set, one thing should have popped off the page, and that's the mode, right? Because as you're writing, you're like, hey, I had to write this number multiple times. So on number 1, what mode sort of pops off to you?
42.
42. Number 2, what mode pops off?
58.
58. There's 2 of those. Now number 3 is sort of bimodal, right? There's 2 numbers that appear twice.
5 and 6.
5 and 6. And again, one could almost make the argument, since both of those numbers both kind of pop off, really nothing pop. It's a rather small set to have 2 modes. You know what I'm saying? Like if I pull everyone in the school and I get 2 restaurants that stand out, that's kind of neat. But like if I just took the 4 of you and 2 of you were like Chick-fil-A and 2 of you were Culver's, like, is that really bimodal? You're just a split class on what you like best, right? Chicken versus burgers, right? So, and all the other stuff Culver's has. Culver's pretty awesome. But anyway, the onion rings so good. So good. And the custard. Anyway, yeah, they get everybody hungry now. Another thing that you should have noticed is, wow, that number's different. For instance, number 1, all the numbers are in the 40s, except
27 and 60.
yeah, 27 and 60, I want you to circle those. Those are what we call outliers. They don't really fit in, do they?
Yeah.
Do you see any outliers in number 2?
51.
50.
Well, 59 is kind of still right in the middle, right? They're all in the 50s except
82.
82.
Oh, I
Yeah.
said 51.
Well, again, that's still in the 50s, right? They're all in the 50s except this one random. Like, for instance, if a kid, let heaven help them, let's say a kid just really struggles in school. And so they're always failing quizzes, 51, 54, 55, 55, 58, 59. And then when did they get an 82? Teacher's like, yes! Or maybe they're like, I wonder if they cheated. But anyway, one of like 100, they're like, okay, this kid has never passed anything in their life and they just made 100 on my exam. All right, what's going on? But it's an outlier, right? It's just something that's not normal. It's just outside the range. What about number 3? Any of those just kind of, whoa, where'd that come from? Yeah, 4 is right there with 5, which is right there with 6, which is right there with 7. 9's not really that far, and boom, suddenly a 19 out of there, right? Yeah, I would say that that's an outlier as well. Now, the median can be found, now that we've ranked it, with almost no math at all. What's the median in the first set?
5 42.
42, very easy to spot. What's the median in the second set?
58.
58. Good. By the way, notice that's both mode and median in both cases, right? That's a very good measure of center. That really tells you what's normal. The mean may not, because you have outliers, right? But especially on number 2, now I will say this, number 1, do you see that the 60 outlier is about a dozen bigger than the next highest number? And notice 27 is about 14 less than the lowest number, right? They're evenly outliers, aren't they? But what if you had like a 27 and a 200? Do you see the one outlier is way different than a really weird outlier on one end is what's really going to trigger. For instance, if the average American makes $50,000 a year, let's just make up that number, and you've got people living on welfare that are making $10,000 a year. Okay, that's a big gap, $40,000 difference. But what about the billionaire? I mean, that's literally almost $1 billion difference from the 50,000 guy. That's a much stronger outlier than the other. So it's not weighted evenly. Like here's kind of normal, and here's like, yeah, it's lower. And there's, whoa, that's way higher. Okay, that's really going to mess up distribution. That's really going to mess up your mean, which is why the mean isn't always the best true form of averaging something. Kind of like on number 3. The only outlier is way on the one end, right? That's really going to mess up your mean. Number 2. Your outlier is just one of them, and it's way on that one end, 82. That's over 20 bigger, right? That's going to mess up the mean. So that's why the mean or the average isn't always the best indicator. Now, it is what we do for your grades. So the moral of the story is, make sure you don't have any outliers in your grades, right? Don't allow 30s, 20s, 10s, zeros, you know? Keep it in that 60 to 100 range, preferably 90s and 100s, you know? But, you know, keep it in that top range there. All right, moving down. I want you to do numbers 4, 5, and 6. You're going to find the mean, the median, and the mode. Notice, if you need to round to the nearest tenth, do so. Before you do any of that, what are you going to have to do first, though?
Order.
Rank it. Put it in order. So numbers 4, 5, and 6, finding mean, median, and mode. Let's go ahead and see how we did on 4, 5, and 6. Number 4, what did you get for the mean, Alana?
15.
Well, round to the nearest tenth. It shouldn't come out evenly to 15.
Well,
15.
it's 15.1.
There we go. 15 and 1/8, 15.1, right?
Oh.
So it said round to the nearest tenth.
I didn't know.
What about the median?
I got 15. Well, it's 14.5.
Right, 14 and a half. It's right in between 14 and 15, 14 and a half.
Yeah, and then there's no mode.
And no mode. There we go. So 15.1, 14 and a half, no mode. Notice that mean and median are pretty close together. So it's a pretty good estimate of what's truly middle for this. Though I would say you do have an outlier like 2. Seems a really strange small outlier there. Number 5. What did you get for your mean, Joshua?
I got 197. 197 and 1/5.
Good, or 197.2 if you were going decimals there. What about the median?
150.
150. Notice how different those numbers are? That's because this data set is everywhere. There's only 5 of them. It's really hard to say there's a true middle when there's such a small data set. And the mode, of course.
No mode.
No mode. Nothing occurred more than once. Number 6. What did you get for the mean, Lana?
9.
Good, or 9.1, right? I think it was 9 and an 1/8 again, so 9.1. What about the median, Joshua?
7.
That's 7,
I
Mom.
got 8.
Should be 8. 8 was the number right smack dab in the middle. And
divided by 2 is... Did I put...
all right, there's 9 numbers, so it's 9 and 1/9, by the way, would have been the mean, so 9.1 repeating, or 9.1. But 9 numbers, so the very middle value is an 8. If you just go in order, there is one set middle value, it's the 8. What about the mode, Lana?
5.
5. There 5 occurred a couple of different times. Questions on mean, median, mode?
What was the median number?
9.1 repeating, or 9.1? Because you should have added it all together and gotten 82, I believe, when you add it all together. Is that right? Yeah, 82 when you add it all together, and when you divide that by the 9, gets 9 1/9 or 9.1.
I don't think my numbers are right.
When you added them together?
Cause, like, these are the middle for me.
Okay, so the 3, then a 5, then a 5, a 6, then an 8. You forgot to copy the 13 down, which would have been there. Yes, that's what it was. You forgot to copy the 13. That's why it added wrong, the median was wrong. So yeah, make sure we don't lose any numbers. Same thing happened to Lana on that one earlier. All right, tell you what, let's do 7 and 8. We'll leave off on 9 for now. I don't think we have time to get to that. But if you want to do 9, you're welcome to. But at least do 7 and 8. There we go, Scott. See if you can get number 9 done before I call time. Hayden has faith in you. He's nodding his head back here like, yeah, Scott can do it. We know Scott. Just another minute or so. Finishing up 7 and 8. let's go ahead and take a look at this together. Number 7, I would say this is largely free of outliers. Maybe you'd call 120 an outlier, but it's really not that far off. So the mean and the median are going to be very close together. We should get a mean, Joshua, of
101.5.
Good, 101.5 or 101.5. And the median, Lana, not too far off of that,
99.5.
99.5. There is no mode. Number 8, there are 2 crazy outliers. What are they, Joshua?
120, 30, and 51.
I wouldn't say 51's necessarily that far off of 49, which isn't that far off of 42, which isn't 8 is just so small.
Yeah.
So there's a crazy outlier up high, there's a crazy outlier down low. The up high outlier is the crazier one though, so it's going to shift the mean higher than it really should be. The mean on letter of number 8, Lana,
48.7.
48.7, while the median is probably the better measure of center, Joshua.
42.
42, and there is, again, no mode. Number 9, Scott, if you got that far, should have gotten a mean of 2.5, a median of 2.5, and a mode of 2.5. All right, your homework for this evening. Homework for this evening is to do page 406. Page 406. You dropped something. That was, Scott said it. I was just echoing what Scott just said. Page 406, homework 1 through 6. Page 406, homework 1 through 6. On 1 through 3, it doesn't say to find the mode. I want you to find the mode, which is really super easy. So it barely adds anything. But page 406, numbers 1 through 6 in the homework. On 1 through 3, also find mode. You might just write that in there on page 406 with the directions, where it says find the Rankin, find the median, find the mean. Just write mode with 1 through 3 because I want that also. Also on page 412, do numbers 28 to 33. Page 412, numbers 28 to 33. So a dozen problems for homework this evening. 1 through 6 on page 406, 28 to 33 on page 412. All right.
Thought our homework could be short.
It's not that bad. 12 problems is not that bad. You tell me,
It's
Scott.
just, it's really